Now, coming to the challenge part, what we basically want to achieve is I want to design a layered driver framework where in the kernel space, I will be having two drivers. Okay, as such, I will be having two drivers. One will be the low level I2C driver, and this is the driver. This is the driver where we are going to play around with a peripheral registers. That means I2C controllers register. So we'll be reading a data sheet, and what we will be doing is we will be uh, as per the data sheet, we'll be writing a program to initialize the I2C framework to initialize the I2C controller, and then basically to send something, receive something. So all those things we'll be doing it in the low level driver. So to start with, what we'll be having is we'll be having two functions in it: I2C receive, I2C transmit. So these are the two functions which we will be having. And of course, there will be some initialization functions and all those things which we will go through as and when we progress. Now, what happens is, see this driver which I am telling you, this low level I2C driver, I typically call it as a horizontal. I call it as a horizontal. I use the term horizontal. Now, what do I mean by horizontal? Basically, these are the drivers which don't directly interact with a user space. That means they are meant to do some stuff at the low level. That means sending some data on the bus, receiving some data from the bus. And these guys are not supposed to directly interact with a user space. Now, of course, like till you don't interact with a user space, how do you get the data from the user space? How do you send the data to the user space? So that's why what we do is on the top of that, we have another driver called I2C care.c. And this I2C care.c is basically your character driver. So whatever character driver you have written till now, you're familiar till now, that character driver we are going to write over here. And of course, what it will be having? It will be having a function like open, read, write. Okay, so these are the functions which we'll have. So typically we will register the callback handlers and we will get the device file in the user space by name I2C-drv0. Now what happens? We are going to use the applications like I can use cat or echo on this particular device file, and this will take us to this character driver, and from the character driver, let's say I'm invoking a cat on this device file. It will take me to the myRead function of the character driver, and then it will be going down to I2C receive. Similarly, when I do write, it will take me, let's say I do the echo on this, it will go to my write, and from the my write all the way to I2C transmit. So the goal for this week is very simple. What you need to do is we need to have this framework ready. So first what we did, I just asked you to go through this protocol basics so that we don't have to spend any time over here. Then I told you like you do the initial setup and you build the kernel for the I2C drivers. Okay. And now here comes the part where you have the assignment for the challenge number 1. Okay. So you will get all the instructions over here in the portal where you have the assignment on the I2C character drive on this particular framework, I2C care framework, which we are developing. So make sure you complete all these steps. If you haven't, you need to build the kernel, and accordingly you need to have all the things ready till here, and then you can basically move on to this assignment. So this week you will see over here, you will have challenges like you see P01 framework, P02 I2C init, P03 I2C TXRX, P04 device model, P05 I2C subsystem, integration, interrupts. So likewise, we basically have all these challenges over here. This week's challenge would be P01. The instructions to clone this repository are already available in the portal when you will be doing the initial setup. And here, what you have is you have two files, as I showed you over here. What you have over here, low level driver.c and I2C care.c. Now that's why what you have over here, low level driver.c, I2C care.c, this file. Okay. And what you will observe is there will be some to-dos provided to you. So you see to-do number 1.1. So remember, you only need to focus on to-dos which are starting one dot. Now you see over here, it's like a complete, I can say continuity I have maintained so that you don't have to duplicate the code, copy paste the things. As far as possible, I have avoided that. Now you see there is 8.8, 4.11. So once we move on to that challenge, we will address that. Right now, your goal should be to address all the to-dos starting with one dot. Okay, so 1.1 to probably like 1.11. We have the things till 1 dot, let me see if 12 is there. No, 1.11. So starting from 1.1 to 1.11, you have the to-dos. And you basically need to populate those to-dos. 1.1, it is basically asking us to initialize the character driver. Now you see over here, you have a transmit function, receive function, something like that. And from here, we need to initialize the character driver interface. So what we need to do here, you will find there is something called char drb init over here. What we are going to do, from here we are going to invoke char driver init. And what is this? This is a context. Now, what do I mean by context? Something like, let's say there are multiple controllers of that type, I2C controllers of that type. At that point of time, we'll be needing a context. For time being, you just can say like, when I want to maintain the instance of driver, I maintain this data structure. The things will be more clear once we reach there. Right now, you just use that. Okay, here it is a global variable, and this particular global variable, you pass it, and then you will be doing all the stuff 1.3. I would say we can go to 1.4, create the class, create the device file, all the character drivers concepts. Okay, register the file operations. So file operations are open, read, write, already being provided. You register using cdiv add. Then you go to 1.7, counterpart of that, and 1.10 and 11 is one where we'll be invoking this transmit and receive. Okay, so that means I basically need to invoke, and don't bother of these things. You can just pass anything dummy. Okay, we don't mind. You can just pass it null over here. You can pass the count as 0. So don't get too much worried about that particular stuff. Okay, so because our intention is just to test our framework. We'll be using it as and when we'll be proceeding. So I2C transmit, remember all the arguments, whatever it is expecting, you need to pass here. And sorry, here it would be I2C receive. Okay, and here in my right, I would be invoking I2C transmit. Like that. So these are the to-dos which you need to complete. And anyone, like I think each one of us is familiar over here with a character driver. So we'll be simply as using our character driver fundamentals. Gives me major number 240. Okay, in the sys class, I can just check it out. So this will be my class name. So when you will be writing a driver, probably you can keep I2C DRV as a class name, and I2C underscore DRV0 is my device file name. Now what I will be doing? First, I will invoke echo. Echo means write operation. Okay. So now I'll be invoking a write operation on this. Now what it should invoke? The flow should be from here on, my write should get invoked, and my write should invoke transmit. I2C transmit. Now what has happened? You were here, you were here. From here you invoked echo. This in turn invoked the open and write system call. And this in turn invoked my write in the character driver and all the way down to I2C transmit. Right now in I2C transmit, we have just one string which says I2C transmit invoked. Okay, and here when I do cat, what should be the flow? When I invoke cat, open, read, from there it should invoke receive. So let's see whether we are getting that. That's it. That's the thing which we want to achieve. That's the output which we are expecting. When you write something, it should invoke I2C transmit. When you basically use cat, I2C receive.